This lesson is a review of right triangle trigonometry. We've learned about 45, 45, 90 triangles. We've learned about 30, 60, 90 triangles. And we've learned about tangent, sine, and cosine. And using all those things to find unknown angles and unknown sides of right triangles. So, looking at problem number 1. This is a 45, 45, 90 triangle. The way those work is it goes like this. It goes leg, leg, those are always the same, and this is going to be leg radical 2. So in this case we know that the leg is 9, so that means this other leg is also 9, which means that the hypotenuse is 9 radical 2. Okay, so there's that. Now, let me switch colors. On number 2, this is a 30, 60, 90 triangle. This is the short leg, which I'll just call it short. And we've learned that the hypotenuse is always equal to double the short leg. And the long leg is really the short leg times radical 3. Alright, so since we know that the short leg is 8, because of the 8 right here, then that means x is going to equal 2 times the short leg, so that's 2 times 8. So that's going to be 16. And we know that the long leg is going to be the short leg root 3. So again, if I take that 8 and put it right there, that means 8 radical 3 is going to equal y. Alright, now looking at number 2 again, I told you that this was leg and leg. So that means this hypotenuse is equal to leg radical 2. We will have to work with the 12 because that's the only thing that I've got. So in order to solve this equation for the leg, I need to divide by radical 2 on both sides. So if I divide by radical 2, that's going to give me 6 radical 2. So the leg is 6 radical 2. Okay, so that means that x and y are both 6 radical 2 because they are both the leg. So x equals 6 radical 2 and y equals 6 radical 2. All right, number 4. Got to read the directions to know what I'm doing. Find the sine, cosine, and tangent of angle A. Express each value as a decimal. Now, my wonderful students very often get this question wrong because they look at these problems and they assume that I'm asking you to find the measure of angle A. You're not being asked to find the measure of angle A. You're being asked to find the sine, cosine, and tangent of angle A. That is very different. So we're supposed to find the sine of angle A, the cosine of angle A, and the tangent of angle A. It does not say find the measure of angle A. So we will not be using the inverse trig functions because that's how I would get angle A. Instead, I'm just going to set up the fractions using the definitions of sine, cosine, and tangent, and I will convert them to a decimal. So sine of an angle is the opposite leg over the hypotenuse. So sine A is going to be 5 over 13. Cosine of an angle is adjacent leg over hypotenuse, so that's going to be 12 over 13. And tangent of an angle is the opposite leg over the adjacent leg, so 5 over 12. Now those are the answers. except for we will, according to the directions, we need to convert these into a decimal to 4 decimal places. So, 5 over 13. Again, I am not going to do like the sine of 5 over 13. I'm just going to do 5 over 13, hit the toggle button to make it a decimal. So 0.3846. All right, that is all. 12 over 13. 12 over 13. 0.9231. Again, notice I'm not hitting the cosine button or the sine button. I'm just converting the fraction to a decimal. So 5 over 12. .4167. Okay, so that's the answer to number 4. Let me draw a line. And okay, we're doing the same thing for all these problems. Okay, we're doing the same thing for all these problems. So, in fact, I'm going to do most of this off camera because it's, it's the same thing. So sine A was opposite over hypotenuse. There it is. Cosine A was adjacent over hypotenuse. There it is. Tangent A was opposite over adjacent. So there it is. Normally I would reduce all these, so this would be like 3/5 and stuff. But I'm going to just go straight to the decimal. So these decimals just end. I could put some zeros on the end of here to make it be 4 decimal places, but these are not rounded. Those are exact values. So that's number 5. Let me draw a line. Now I'm going to do the same thing for number 6. All right, so here's the sine, cosine, and tangent for number 6. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now I just need to turn all these into decimals. I'll show one of them live, 1 over radical 13. I'm just going to use my TI-30 XS multi-view. So 1 over radical 13. Okay, that's radical 13 over 13, by the way. But that is 0.2774. Okay, so I'm just going to do the same thing for the other 2 off camera. Okay, so here are the decimal forms of these answers. So again, these are the final answers. If I ask you for the sine, cosine, or tangent of an angle, just set it up, okay, and turn it into a decimal. Do not do the inverse trig function, and do not do the sine of this, all right, because I didn't ask you to do the sine of A. This is it. You stop. All right, that's one of the most commonly missed problems because kids don't know when to stop doing that. Okay, number 7, 8, and 9. So number 7, use radicals, not decimals on this one. So we can use radicals, all right, square roots, because this is a special triangle with a 30, 60, 90. So let's not use tangent, sine, or cosine on this. Again, this is the short leg, and so the hypotenuse is going to be double the short leg. And this side over here, if anybody ever asked me for it, would be the short leg times radical 3. But anyway, the only variable we're being asked to find is x. And x should be 2 times the short leg. All right, the short leg is 7. So that's just going to be x equals 14. Okay, no tangent, no sine, no cosine. Now, for number 8, this is not a special triangle. So I will have to use tangent, sine, or cosine. From the perspective of this angle, of course the 14 is the hypotenuse, but this x is adjacent. Adjacent over hypotenuse, that is the cosine function. So that's how I know to do cosine. So I will do cosine 52, that's a weird looking 52, equals adjacent over hypotenuse. So that's x over 14. To solve this, I will simply multiply both sides by 14 like so. That way these 14s will cancel each other out. So that means that x equals 14 cosine 52. Calculator. So that's 8.6. If the directions don't tell you how many decimals to use, go ahead and do 1 decimal place, unless your teacher says otherwise. But that's what I say. 1 decimal place is generally pretty good. That's the nearest tenth, by the way. All right, anyway, number 9. We're back to radicals. No decimals for this one. Again, because this is a 30, 60, 90 triangle, and this one over here is a 45, 45, 90 triangle. We kind of have to start with the 45, 45, 90 triangle because that's the only number that we're given. I'm going to switch to blue so it doesn't get confused with the red over there. So the hypotenuse is the one that's always the short. I'm just going to use S because I'm running out of space. The hypotenuse, no, it's not short. It's a leg. For a 45-45 triangle, it goes leg, 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 radical 2. I'm using L for leg. So if I want to find out what the legs are, I will have to divide both sides by radical 2. So if I divide by radical 2 right now, I don't even need a calculator for this because these radical 2's just cancel each other out. So that tells me that the leg is equal to 4. So that means both of these are equal to 4, including this x is 4. So right there, I know that x equals 4. Okay, so in the meantime, that means that this is 4. So now I can do the 30, 60, 90 triangle. Now remember the way those triangles work, it's all about the short leg. So this will be the short leg because there's a 30, it would be up here. But that means this is the long leg, okay? I feel like I need to do this somewhere. I'll do it up here as part of this problem. All right, this 4 is the long leg. So this 4 should equal the short leg times radical 3. I'm using S for the short leg. So I need to divide by radical 3 to find out what the short leg is. So if I divide by radical 3, what I find out is the short leg is equal to 4 radical 3 over 3. Okay, that is the short leg. Okay, now here's the key. To get the hypotenuse is always it's always 2 times the short leg. All right, so that means y is going to equal 2 times 4 radical 3 over 3. Okay, so that's going to be, so y is going to equal 2 times 4 radical 3 over 3, which means that y is going to be 8 radical 3 over 3. Which really, you can do that in your head. Okay, so that was a little awkward because of how big the numbers are, you know, being fractions and radicals and all, but that is how you do number 9. Okay, moving on. Now we need to solve the triangle. Remember that solving the triangle means finding all the unknown sides and the unknown angles. So if I'm going to find x and y, like first let me just get this out of the way. We should be able to find this angle right here by doing 90 minus 29. Never forget that. So right there, that's going to be 61 degrees. Now, so anyway, find that 61 degrees. But back to the normal stuff. You have to decide which one of these sides you want to find first. I'll just go in alphabetical order, and so I'm going to find x next. So, looking at the x that I'm trying to find, and looking at the two numbers that I'm given, the 3.5 and the 29, these are the three things I will look at to decide which trig function I'm going to use. Opposite hypotenuse, that is the sine function. So I'm going to go sine 29 is equal to opposite, opposite over hypotenuse. Now, when the variable is in the denominator, that's when we do this reversal thing. Okay, so this is going to become, if I can squeeze this in here, whoops, I already messed up. This is going to become x equals 3.5 over sine 29. Now that I can just put in my calculator. So I'm going to get, let's see, where should I store this? So I'm going to get x equals 72.2. Okay, so that's x. Now it's time to get y. Okay, so now, well, I might as well have left that highlighted. So now I'm going to focus on the y. So looking at these three things, which trig function am I about to use? Let's see, I've got opposite and adjacent now. That is the tangent function. So I'm going to go tangent of 29 is equal to opposite over adjacent. So 3.5 over y. Again, when the variable is in the denominator, I will do the reversal. So this is going to give me y equals 3.5 over tangent of 29. And I will put that in the calculator. And that is 6.3. Okay, so we have solved the triangle. We found the angle and we found the two sides. Okay, so number 11. Let's find this missing angle first. If I subtract from 90, I get 47. So I've got that. Again, I'm going to find x first. So if I'm going to find x, and I've got the 43 and I've got the 8.2 to deal with. That's opposite over adjacent, so that is the tangent function. All right, so I'm going to go tangent 43 equals opposite over adjacent. All right, the variable is in the denominator, so let's do the reversal. So x equals 8.2 over tangent 43. Calculator. All right, so x is 8.8. All right, now let's find y. Okay, so instead of x, now I'm looking at y. Now I'm looking at opposite over hypotenuse. That's the sine function. So I will do sine 43 equals opposite over hypotenuse. So 8.2 over y. Again, the unknown is in the denominator, so I will do this reversal. So that's going to give me y equals 8.2 over sine 43. Calculator. So that's y equals 12.0. All right, that's it for number 11. Let's move on to number 12. Same thing. Subtract from 90 and you get 66. Let's find x first. If I use the 33 and the 24 that I'm given, that's adjacent and hypotenuse. That is a cosine function. So I'm going to go cosine 24 is equal to adjacent over the hypotenuse. The unknown is in the denominator, so I will do the reversal. So that's going to give me x equals 33 over cosine 24. Calculator time. So x equals 36.1. All right, now let's find y. So instead of x, now I'm looking at y. So now this is opposite over adjacent. So I'm going to use the tangent function again. All right, so I'm going to go tangent 24 is equal to opposite over adjacent. To solve this, I just need to multiply both sides by 33. All right, since the variable is in the numerator. If I multiply by 33, those 33's cancel each other out. So that's going to give me y equals 33 tangent 24. I could just put that in the calculator. And that is 14.7. Okay, so that is it for number 12. Okay, number 13. Number 13 is a little bit different because we aren't given either of these two angles at first. So for that reason, we need to start by doing the Pythagorean theorem. So if I want to find x here, I'm going to do the Pythagorean theorem. A squared plus b squared equals c squared. And x is the hypotenuse here. So that means x squared should equal 23.7 squared plus 8.2 squared. So if I want to get x by itself, I'm going to have to take the square root of both sides. And I like to just take the square root of all of it. Instead of squaring these separately, I let the calculator do the work for me. So this is going to give me x equals. And I just put all this into my calculator. So here's what I get. So this is just typed all in my calculator, like I said. And that's going to give me 25.1. So x is 25.1. Now I need to find these angles. So I'll just go in alphabetical order. So say if I want to find angle M. And of course I'm going to use the two numbers that I was given. Now, because I'm looking for an angle, that's when you wind up doing inverse trig functions, anytime you're hunting for the angle. So I'm going to set this up. This is opposite over adjacent, so I'm going to do the tangent function. So I'm going to write tangent of M equals opposite over adjacent. So 8.2 over 23.7. Okay, now if I want to find angle M, I will do the inverse tangent. So it'll be inverse tangent of 8.2 over 23.7. That will find this angle for me. And I can just put this in my calculator. And I got 19.1 degrees. Alright, so that is the measure of angle M. Now I could do 90 minus this, and that would find angle N for me. I'm going to go ahead and just do it all over again though. But you could do 90 minus this to check your work. So if I want to go back and find angle N this time, so here's angle N, now suddenly I'm dealing with, well, you know what, same thing. I'm still dealing with opposite over adjacent. It's just the fraction is upside down. So I'm going to start doing this. It's still going to be tangent. So tangent of N is equal to opposite over adjacent. So 23.7 over 8.2. And again, if I want to find N, that's going to be equal to the inverse tangent of 23.7 over 8.2. And once again, I can just put that in my calculator. So I am getting 70.9 degrees, which is the same thing I would have gotten if I just had done 90 minus 19.1. Okay. Number 14 is practically the same thing. Let's start off with some Pythagorean theorem. So x squared plus 27 squared is equal to 32 squared. Notice the hypotenuse always goes by itself. I need to subtract 27 squared from both sides. So that's going to give me x squared is equal to 32 squared minus 27 squared. And then I'm going to take the square root of both sides to get x by itself. So that's going to give me x equals. Again, I will just put that whole thing in my calculator. And I get 17.2. So that is x. Now, I also need to find angle R and angle T. So, angle R and angle T. Let me start by finding angle R. Okay, well, I've got adjacent leg and hypotenuse. So it looks like I'll be doing the cosine function. So I will do cosine of R is equal to adjacent leg over the hypotenuse. That means R is going to equal the inverse cosine of 27 over 32. Calculator. I'm getting 32.5. So R is equal to 32.5 degrees. Okay. All right. Similarly, I can find angle T. Again, I could do 90 minus 32.5, and that should give me angle T. The only problem with doing that is if I did make a mistake on angle R, I'm just going to automatically get angle T wrong as well. So a lot of times the smartest thing to do is to do it all over again and just check your answer by subtracting from 90 just to make sure. So I'm switching from angle R to angle T. So now these numbers become opposite and hypotenuse. So that is the sine function. So now I'm doing sine t is equal to opposite over hypotenuse. All right, that means that t is going to equal the inverse sine of 27 over 32. And I can just put that in my calculator. I'm getting 57.5. So that is the measure of angle T, and that's degrees. Okay, so that was number 14. Let's move on to number 15. What is the area and perimeter of this triangle? Well, please remember that the area of a triangle is 1/2 base times height. We have the base, but we need the height. So I'm just going to call this x for right now. we could find x, couldn't we? Because if we use the tangent function, opposite over adjacent from the 40, so I'm going to use the tangent function to find this unknown side over here. I'll do it over here. So tangent of 40 will equal opposite over adjacent. And now I can just multiply it by 24 on both sides like this. That way these 24s cancel each other out. So that's going to tell me that x equals 24 tangent 40. Calculated. That is just 20.1. Okay, so that tells me that this side of the triangle right here is 20.1. So I've got the base and the height. So I could go back and find the area now. So the area is going to be 1/2 base times height. So that means the area is, I'm just going to put this in my calculator, so that's 241.2 square units, whatever the units are. So that is the area. Now we need to find the perimeter. We need area and perimeter. Of course, the perimeter is the sum of all the sides. So to find that, we're going to need to find this other side, which I'm going to call it y. Okay, so if I'm going to find that, now I'm looking at the adjacent leg and the hypotenuse, because y is the hypotenuse. So I could do the cosine function. So I'm going to do cosine 40 is equal to adjacent over hypotenuse. Again, when the unknown is in the denominator, I can do this reversal. So I'm going to get y is equal to 24 over cosine 40. So I will go to my calculator. That is 31.3. Okay, so I can go ahead and put that for y, so that's 31.3. Okay, so now I'm ready because I've already had my my 20.1, and now I've got my 31.3, and I've also got my 24. So I can now do the perimeter. So the perimeter is just the sum of all the sides. So the perimeter is going to be 20.1 plus 31.3 plus 24. Okay, I'm just going to put all that in my calculator. And that turns out to be 75.4. So that is the perimeter. Okay, now last but not least, for this one, I see that this length is 48. And see, by the way, this is number 16. Okay, I see that this length is 48, so that means that this is 24 and 24. Okay, maybe I should back this up a little. Okay, so since these are 24, if I want to find the measure of angle C, so focusing on angle C, and using the 24 and using the 7, this would be opposite over adjacent. Okay, so that means tangent. So tangent of C is equal to 7 over 24, which means that C is going to equal the inverse tangent of 7 over 24. Calculator. And that is 16.3 degrees. And that's all we needed for number 16. That is it for this assignment.